Hello guys, I hope you are all doing well. In this video, we are going to continue our series in which we are solving the GATE question on C programming language. In this video also, our topic will stay the pointers. So let's begin. We have our first question in which we have to find the output of these two lines, and two functions definition are provided here. Now first of all, it is declared a single pointer, a character single pointer, right? So there is a single pointer, two single pointer with the name str1 and str2, right? Both single pointer will having their own address. Then it is written str1 equals to height. So basically there is some array, let's say h, I and then null character, and also by for by, b, y and e, and then there is a null character, right? And the base address which can be pointed in this location are pointing to the starting of these arrays, okay, or character array. For example, if the base address is 4090, let's say, then it will be 4091 and this will be 4092, and let's say this address be 5042, then 5043 and so on, okay. So right now if I do here printf of %u and then I write here str1, then it will give me output as 4090, okay, because the str1 is holding the base address of this location, okay. So here it will give me output as 4090. Basically str1 is holding the base address of our string. Similarly str2 will give me address as 5042, right? This is 5, base address of our character array, right? Now str1 is pointing to this location, str2 is pointing to this location, and let's suppose the address of these pointer variables are 9024 or 1004, right? These are the addresses of these variables, and these are what they are holding. Since they are single pointer, they will be holding some addresses, right? So this is pointing to this location and this is pointing to this location. Then it is sending str1 str2 to this function, okay, in which two character pointers are defined. So there are two pointers, let's say this is s1 and this is s2, right? So there will be s1 and there will be s2. Now it is sending str1 and str2, basically the address holded by this location, right? So let's say this will be 4090 and this is 5042, then s1 will become equals to str1, okay, and s2 will become equals to str2. Whatever we are sending here, this will be like, we can write here something like asterisk s1 to divide the statement, then s1 equals to str1, okay. I am dividing this line into two pieces, right? So now if I do here %u of s1, then it will also point me to the same memory location, that is the 4090, right? Similarly, if I do %u of s2, it will also point me to the location of str2, which is 5042, okay. You can take any addresses, it is just for the explanation. Now s1 is also pointing to this location and s2 is pointing to this location, okay. Then it is written char asterisk temp, so a temporary variable has been created, okay, and currently it will be holding the address, some garbage address we can say. Then it is written temp equals to s1, so temp equals to s1, so now temp will point to the location which is pointed by the s1, okay, or I can write here temp will give me output as 4090. If I do %u and then write temp, then it will give me output as 4090, okay, same address as holded by the s1. Then it is written s1 equals to s2, it means that whatever it is holded by the s2, change it to s1, okay. So now s1, which was previously pointing to this location, now it will be s1 equals to s2, which means it will point to this location, okay. So now if I write here printf of %u and then I write here s1, then it will give me output as 5042. Why? Because it is written s1 equals to s2, s2 was 5042, so s1 will also become 5042, okay, let it be 5042. Then it is written s2 equals to temp. So S2 will point to now S1, okay, because temp was pointing to S1 or 4090. So if I write here printf %u of S2, then it will give me base address of this location. Basically, in the beginning, S1 was pointing to str1 and S2 was pointing to str2. Now, after this processing, S1 is pointing to this location or this str2 string and S2 is pointing to str1 string, right? So then it is closed and the control will go back here. Now it is written %s, str1 and str2. Now if you see here, no changes are performed in this location, okay. Only the temporary changes in the additional variables have been done, but in the actual variables no changes have been done. So here str1, printf %s str1 will give us output as high and this will give us output as buy, right? Now here we are sending the reference of our pointer variables, basically the main address of our pointer variables, right? So our function is fun2, right? So there is s1 again. Since it is a double pointer, it will be holding something s1 and then there will be something like asterisk of s1, okay, and there is also s2. There will be also asterisk of s2, then end of s2. Now if you don't know about this, I have made dedicated videos on the pointers, you can check that out, in which I talked about these concepts, right? Then a temporary variable has been created again. So let's say this is temp and temp, right? Then it is written temp equals to asterisk s1, okay. Now before that, here it is written char asterisk asterisk s1. Now what it means that, first of all, if I divide this line into two parts, this means asterisk asterisk s1 and then s1 equals to end of str1, okay. So s1 is pointing to the str1, okay, so it is pointing to the end of str1, or I can write here 9024, okay. Now before I move further, let's say I write here printf of %u and I write here s1. Now it will give me output as 9024, okay. Basically currently it is holding this address, okay. Now if I write here asterisk of s1, now what it will give me output? It will give me output as 4090. Why? Because end of s1 means 9024, then s1 means 9024, then it is saying what is present in this address, okay. So what is present in this address? This is 4090. So here it will give me output as 4090 or address of holded by str1, okay. Similarly, same case for the str2. So then we have our temporary variable, then it is written temp equals to asterisk s1. Now basically it means that asterisk s1, let me write here 4090, right, and asterisk of s2 will be 5042 and end of s2 I am considering here 1004, right. Then it is written temp equals to asterisk of s1. So temp will now pointing to the address location of 4090, or we can say the base address of our first string, okay. Then it is written asterisk s1 equals to asterisk s2. So it is saying that whatever is present in the asterisk of s1, it means that whatever is present in this address, okay, asterisk s1 means whatever is present in this address, okay. S1 is this location and what is present in this thing, okay. So asterisk of s1, change it to asterisk of s2. So basically it is saying change this into this, okay. So this will become now 5042, right. And here also we can write here, now this is 5042, okay. Now let's say I do here printf of %u and I write here end of str1. str1 will give me same output as 9024, okay. But if I now write here printf %u asterisk of s1, asterisk of s1 means what is present in this address, what is present in s1, what is present in end of str1. So what is present? str1. So now it will give me output as 5042, okay. So basically currently, before I go further, these two variables are pointing to this string, right. Now it is written asterisk of s2 equals to temp. So basically it means that whatever is the value or whatever is the address holded by this variable, change it to whatever is this, okay. So this will now point to 4090, right. So it means that this str2 will now be pointing to this location and this str2 will point to this address, okay, or this string, right? Similarly here I can also write here 4090. Okay, now in the first function the changes are done temporarily, which means that actual variables which are str1 and str2 were not affected, but in the f12 the actual variables which are str1 and str2 are affected. Okay, that is the reason the question becomes little bit of complicated. Okay, then it is written printf of %s str1 and str2. Now str1 is pointing to base address of this string, so now str1 will give me output as by, and str2 is pointing to this location, that means it will give me output as high. It will give me output as high. Now our final output will be high, by, and high. Okay, so this will be our output. Now let's see the another question. Now again in this question we have to find the output of this line. Okay, first of all, a two-dimensional array has been initialized with the content 1 2 3 4 5 up to 20. So I had written here 1 2 up to 20. Note that these are in contiguous fashion, right? So we can say here that the first 5 elements belongs to A0, right? Since a two-dimensional array is a collection of one-dimensional array. Okay, so always remember that. Then next 5 will belong to A1, next 5 will belong to A2, then so on, right? Let's say I want to access this element, then I'll write here A0 0. Why? Because these all will belong to the first dimensional array. So 0 0 0 1 0 2 0 3 0 4, again 1 0, or we can say the first element of A1. Okay, so to access the first element of A1 I'll write here 0. Okay, so A1 0 will give me output as 6. The base address, let's say it is 4096. Okay, and I am considering integer is of 2 bytes, so the next address will be 4096, right, and so on. So to access the base address we already know we use asterisk of A, right? So if I write here asterisk of A, it will give me output as 4096, right? If I do here asterisk A plus 1, then it will give me output as, this is 4098, output as 4098, right? So to access the adjacent location we use asterisk A. Now one more thing is that the A will tell me the base address of our first array. Okay, base address of first one-dimensional array. Similarly, A plus 1 will point to this location, A plus 2 will point to this location. Now if I write here A printf of %u A, it will give me address as 4096, right? And if I do here A plus 1, then what address it will be pointing to? So it will be pointing to, let's say this is 98, then 0, then 2, then 4, then 6. So this will be 5006. So it will give me output as 5006. Now either I can write here A plus 1 or I can write asterisk of A plus 5. It will also point me to the same memory location, which is 5006. So this will also give me the output as 5006. Now another thing that I had talked in the representation of 2D array as a pointer video, that to access a particular value in 2D dimensional we have to use double star. Okay, if we are not seeing the double star, that means we are still pointing to some memory location, not the value present residing inside that. Okay, so remember that in two-dimensional array double asterisk will be used to access the values present in some address, right? So we have written here asterisk asterisk, then A plus double asterisk A plus 2, right? So first of all let's solve this part. So it is written A plus asterisk asterisk A, and then it is plus 2. Okay, so A will be pointing to this location, right? We know asterisk A will also give me the same address, but now if I do here double asterisk A, it means that what is present inside this address. So here it will give me output as 1. Okay, so this is giving me 1, right? Then it is written asterisk asterisk A plus 2. So basically 1 plus 2, which means A plus 3. Okay, so this was our A plus 1, this is our A plus 2, then this will be our A plus 3. Okay, so A plus 3 is pointing to this memory location. right? Instead of writing a plus 3, we can also write, let's say asterisk a plus 5, a plus 6, a plus 7, 8, 9, 10, 11, 12, 13, 14, 15. So either I can write asterisk a or a plus 15. Okay, so to make it better, I write here asterisk a plus 15 or a plus 3, right? So our output of this is basically a plus 3, right? So now we will take this entire part, right? So this is like asterisk of, then our output has been a plus 3, then it is plus 3. Okay, so a plus 3 is pointing to this location. Then even if I do asterisk here, then it will give me the address. Okay, because there are no double asterisk yet. I am not considering here right now. Since there is only one asterisk, it means that whenever there is one asterisk and if I am adding something to that, it means the next, we are talking about the next adjacent location. Okay, so a plus 3 means we are pointing to this memory location, and now we are also using asterisk, which means that after doing any addition or subtraction, it will be pointing to the next contiguous memory location, not the next array. Okay, not the next one dimensional array. So a plus 3 is pointing to this, and now it is written plus 3. So plus 1, plus 2, and then plus 3. So this entire expression will be pointing to me to this location, that will be equivalent to asterisk of a plus 16, 17, 18. Okay. Then it is written here asterisk, right? So asterisk. Now we are seeing that there are basically double asterisk. Asterisk a plus 18 is pointing to me to this location, and then there is asterisk, which means what is present inside it, the output will be then 19. This question might look a little complicated here, because most of the time we see here that whenever I am using asterisk, which it means that we have to dereference the things. So someone can ask me that a was pointing to this location, let's say 4096, then asterisk a should give me the value itself, that is the 1. But this is not the case when we are dealing about the two-dimensional array. Okay, this is a misconception that the pointers and arrays are the same thing, but they are not. Remember that in two-dimensional array, a and asterisk a is pointing to the same memory location. Okay, and this will also give me address as 4096, right? Only when I am using double asterisk a, it means that we are talking to dereference some value. Similarly, if I write here, let's say a plus 3, and then I am doing double dereference. Okay, so double dereference means to know the value. So a plus 3 will point me to this location. Let's say this was a plus 2, and we already know this will be our a plus 3. Then we are double dereferencing it. Okay, we are double dereferencing it, which means tell us the value present inside it. Okay, so this will give me output as 16. Okay, but now let's say I am writing here a plus 3, and then it is like this, and then it is asterisk again. Now a plus 3 will point me to this location. Okay, then there is asterisk, right? There is asterisk, and let's say I am also writing here plus 2, right? So a plus 3 is pointing to this location. Now a single asterisk has been arrived. Okay, after the single asterisk has arrived, even I do addition or subtraction, now the adjacent location will be pointed. Okay, so there was single pointer, and then there is this location, and then we are adding 2. So basically with the single asterisk, it means that point to the next second location, right? So now it is pointing to this location. Now I can equivalent to a plus say 17. This is equivalent to asterisk of asterisk a plus 17. Okay, and then we are left with asterisk. Now it is saying what is present in this address, which will be 18. Okay, this was another example, but here our output, final output will be 19. Now let's look at the another question. So this question is similar to the previous one, in which we have to find the output of this line, and in the question it is given that the base address of a two-dimensional array is 2000 and integer is of 4 byte, right? It means that the difference between the two adjacent location will be 4. Okay, this is 2. So I had written the two-dimensional array in a contiguous fashion, right? So as I also described in the previous question, this will be our asterisk of x or x, right? Then this will be asterisk x plus 1, asterisk x plus 2, asterisk x plus 3, asterisk x plus 7, asterisk x plus 8, and so on, right? And each one-dimensional array is having 3 elements. So basically these 3 elements will belong to x0, then 3 elements will belong to x1, and then 3 elements will belong to x2, and finally these 3 elements will belong to x3, right? So if I do here printf of x, it will give me output as 2000, or I do printf of asterisk x, it will also give me output as 2000. Okay, next array is this one, so this is will also be equivalent to x plus 1, then this is equivalent to x plus 2, and here this is 2036, or I can write here asterisk of x plus 9, or it is equal to x plus 3. Okay, so first of all it is written printf of %u x plus 3. Now x plus 1, x plus 2, x plus 3, basically x plus 3 will give me the address of this location, so it will give me output as 2036, right, 2036. Then it is written asterisk of x plus 3. Now asterisk of x plus 3 will also give me output as 2036. Basically, as I told you in the previous question also, that until you are encountering the double asterisk, it means that we have to tell what is the address. Okay, so still it will give me the address as 2036. Okay, then it is written asterisk of x plus 2 then plus 3. So asterisk of x plus 2 then plus 3, right? So x plus 2 will point me to this location, right? Now there is a single asterisk. Now whenever there is a single asterisk for an address, it means that after addition we will be talking about the adjacent locations. Okay, we will not be talking about the next arrays, we will be talking about the next adjacent location. So here also, here it is written asterisk x plus 2, so x plus 2 is pointing to me this location, then it is written asterisk then plus 3, so it means that adjacent third location. So this is our first location, this is our first location, then plus 2, and this will be our plus 3. So basically this here is also pointing to me the same memory location, that is the 2036. Okay, if I had written here, let's say asterisk, then in that case it will give me output as 10. Okay, since there is only one star, it means that our output will be some sort of address, that will be 2036. So this gave us 2036, and this also will be 2036. Okay, so our final output will be 2036, 2036, 2036, right? Now let's look at the another question. Now we have our last question for this video, in which we have to find the output of this line, basically to calculate the sum. Now first of all, an array is defined here with the content 2, 4, 6, 8 and 10. I am considering here integer is of 2 byte and the base address of let's be 2036, right? Then there is a variable sum. Let's create a variable sum, right, which is currently holding the value of 0. Okay, and there is a pointer variable. This is our pointer variable, and this is currently pointing to this a plus 4 location. So this will be our a plus 1, a plus 2, a plus 3, and this will be a plus 4. Basically right now it is pointing to a plus 4, or I can write here 2044. Now one thing before I move further is that if I do here %u a plus 4, or I write here %u b, both will give me address as 2044, right? It means that both are pointing to the same memory location, either a plus 4 and either b. Okay, or if I do dereference here asterisk of a plus 4, since it is a single array, not the two-dimensional array, it will give me output as 10, and similarly asterisk of b will also give me output as 10. Okay, so remember that before we move further. Now it is written for I equals to 0, I less than 5 and I plus plus. So basically first of all I will be 0, right? Then it is written asterisk b minus 1. So asterisk b, which I talked just now, will give me output as 10. So this will give me output as 10. Then it is written minus I. So minus 0, 10 minus 0, which will give me as 10. And then it is written b minus I. So b minus I means that b is pointing to this location 2044, and b minus 0 will also be pointing to this location. Okay, and then it is written asterisk. So what is present in this address? So what is present? It is 10. Okay, so this is 10 and minus 10. Then it will be sum plus 10 minus 10, which will be sum equals to sum. That means sum will stay currently 0, right? Then there will be the next iteration of our loop. I will be incremented and I will become 1. Okay, I will be 1. Then it is written asterisk b minus I. So b is currently pointing to the same memory location, then it is minus I. Now this is 10 and I is 1. So this will be 10 minus 1, which means 9, right? And here if we see b minus I or b minus 1, it means that whatever is the address of b, go 1 back. Okay, we already know from the pointers arithmetic. If you don't know about pointer arithmetic, you can check out that video. B minus 1 or 2, it means that previous locations, right? Or if I write here, let's say in simple term a plus 4, then b is a plus 4, b is a plus 4, then minus 1, it means a plus 3. Okay, so now b minus 1 is pointing to this location, and then it is written asterisk. So what is present in this address? It is 8. So this will give me 8. So now it is 9 minus 8, which means this equivalent to 1. Okay, so sum will become sum plus 1, which means sum will be now 1. Okay, previously sum was 0, right? Then next iteration I will become 2. Okay, I will be 2, and then it is written asterisk b minus I. Basically 10 minus I, which means 10 minus 2, which means 8, right? And then it is asterisk b minus I. So b minus, let's say I write here b minus 2, so 1 back and 1 back. So this location, and what is present? 6. So this will give me output as 6, and this is 8 minus 6, which will be 2 here. Okay, and the previous value of sum was 1, so it will be 1 plus 2, which will give me 3. So now sum will become 3. Okay, then there will another or next iteration in which I will become 3. So asterisk b minus I means 10 minus 3, which means 7, and asterisk b minus I. Now b minus 3, so 1, 2, 3, 4, so 7 minus 4, right? And this will give me 3 as an output, right? And currently the value of sum was 3, so this will be 3 plus 3, and sum will be now 6, right? Then there will be another iteration for, let's say I equals to 4, right? Sum is currently 6, and now asterisk b minus I, it means asterisk b, which means 10 minus 4, so 10 minus 4, it will give me 6, and then b minus I, which means b minus 4, it means 1, 2, 3, 4, basically in this location. So this will be 2 here, right? So 6 minus 2 is 4, and 6 plus 4 is 10. So sum will become finally 10. Now after I will increment, I will become 5, and this condition will be false. Okay, then the control go back here. It is written printf %d sum, so our output will be 10. Final output or final sum is 10. One thing to note here is that here whenever there is a for loop, only one line will be executed in case there is no curly braces. Okay, there was no curly braces, so only the first line is executing again and again. For multiple lines we have to use the curly braces. Okay, always remember that. And same case is used for the if statements, right? If there is no curly braces, that means only the next statement will be executed in the loop way. Okay, so in this question our final output will be 10, right? So that's all for today, guys. I hope you like the video. If you have any doubt, please comment it down. Thanks for watching, and I hope to see you in the next video with some new questions.